This video was made by Taoping Airlines Math Industry. We hope you enjoy this video and have a wonderful learning experience. Hey, Taoping Airlines Math Industry, and we're going to be taking a look at angles again. So what we're going to review with angles is we understand that there are parallel lines right here. Parallel lines are lines that never intersect or never touch each other. With these lines don't touch each other. For this, for example,
Sweeper, you really should watch the closing doors.
So with the example of SpongeBob and Patrick riding a subway train, the closing doors on the train were examples of parallel lines because before they touch each other, they were close to being closed, and those were examples of parallel lines, lines that do not touch each other. And the other examples was the train tracks. The train tracks are another examples of lines that do not touch each other. So that is the definition of a parallel line. What else we're going to be reviewing is called a transverse line. That looks like this. So a transverse line is a line that is going across parallel lines, or that is striking through the parallel lines. So that green line is going to be transversal. Here's a good way to remember that.
TWA presents the difference between getting you where you're going and leading the way.
Leading the way, TWA. So the reason why we showed the commercial for TWA is because it has the word Trans World Airlines. A transversal line is a line that goes across two parallel lines, and Trans World Airlines is an airline that goes across the globe in the late 1980s and 1990s. So that's what trans mean, across something. If you have noticed when we made this transversal line intersect these two parallel lines, there is something weird about these lines. That here's an angle right here, there's an angle right there, there, and there. So, what these kind of angles are, they are vertical angles. Vertical angles are angles that would be equal to each other, and they also make 360 degrees if you add up all of the angles. Like for example, here's a vertical expression here, a vertical angle here, and another vertical angle here. So, here's something weird. The weird thing is that this angle is going to be equal to this, and this. And the other angle, this, is going to be equal to that, and that. Why does this happen? Let's find out. So here's an example. If this angle is 60 degrees, that angle is also 60 degrees. So, with vertical angles, if the angles are opposite from each other, like they're right next to each other, like 90 and 90, they're gonna equal the same thing. And not only that, 60 and 60 are going to equal the same thing too. So, but what happens if we do this? We added 120 degrees for this one and 120 degrees for that one. These two are going to equal each other. We have color coded for you which is equal to each other and which is different than each other. But since we add the 120, we're going to realize something very special, and we're going to discover it by covering up part of the line. So here's the piece of paper that we covered half of the line. We have 60 and 120. This is going to equal as a supplementary angle, because supplementary angles are 180 degrees. And 60 plus 120 is 180. And that also applies to the bottom one too, 120 and 60. So 180 plus 180, that is going to equal 360. So these two are the same, and these two are the same. So, yeah. But with the other line, it's the same thing. Here's 60 and here's 60. That is also 60, another 60, 120 over here, and another 120 over there. When we add a transverse line through these parallel lines, you're actually going to have two vertical angles. So if you solve some for these, you'll automatically understand that you can insert numbers in for here as well. Let's do a sample problem. So if this is 30 degrees, how many degrees is up here? If we want to solve for x on that angle, we're going to have to cover up half of the page. Now it's a supplementary angle. That is 180 degrees. So 180 minus 30 degrees, that is going to equal 150. So that x is going to equal 150 degrees. So covering half of the line is going to be easy because 180 is a supplementary angle, and the problem is only giving us the 30, so we get to solve what x is, 150 degrees. And there are also questions going to be saying, well, what is this one? Well, since there are vertical lines, 30 and 30 is going to be the same, and that has to be 150 as well. So 150 plus 150 is 300, plus 30 and 30, that is 360. A vertical angle is 360 degrees, making a circle. So that is an example, and we can also write and insert the numbers on here as well. That concludes our definitions and how to solve parallel lines with a transverse line. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. This is video 1 of 2. Watch part 2 on the next video to solve a problem with a variable including these kinds of angles. Taoping Airlines Math Industry, mission out.